AP style free response problem 1. The reaction between NO and H2O is believed to occur in the following three-step process. So you can see step 1 is bimolecular with 2 NO molecules. And then step 2 is bimolecular with an N2O2 molecule and an H2 molecule. And you can see that that is the slow step, slow rate determining step. And then step 3 is N2O2 plus H2 produces N2 and H2O. Okay? So first we're going to write a balanced equation for the overall reaction, then identify the intermediate of the reaction and explain. And then from the mechanisms presented above, a student correctly deduces that the rate law for the reaction is NO concentration squared times concentration of H2. The student then concludes that 1, the reaction is third order, and 2, the mechanism involves the simultaneous collision of 2 NO molecules and an H2 molecule. Are conclusions 1 and 2 correct? Explain. And then finally, part D, explain why an increase in temperature increases the rate constant K, given the rate law in part C. All right, in part A, we're asked to write a balanced equation for the overall reaction. So what that involves is just simplifying the 3 steps. So we're going to first, anything that appears as both a product in one step and a reactant in another step, we can cancel. So I can do that with this N2O2. I can also do it with this N2O. I think that's it. From here, we can just simplify. So look here, we have 1 NO plus 1 NO would give us 2 NO reactant molecules. We also have 1 H2 here and 1 H2 here, which would give us 2 H2 molecules. And what about on the product side? We have 2 water molecules and 1 N2 molecule. So here we go. 2 NO plus 2 H2, that's what I circled in the purple, produces 1 N2 plus 2 H2O, which is what I circled in the blue. Okay. Now that we have a balanced equation, identify the intermediate in the reaction and explain your reasoning. So remember that intermediates don't appear in the final reaction. So it can't be any of these things that we just wrote here. Also remember that intermediates first appear as products. So we create an intermediate in one step that we then use as a reactant or consume in another step. So these things that we canceled, this N2O2 is produced in one step, consumed in the next step. Same thing with this N2O, produced in one step, consumed in the next step, and neither appears in the final reaction. So those are our intermediates. Both N2O2 and N2O are intermediates because they appear as a product in an elementary step and then as a reactant in a following elementary step. Since they cancel out, they do not appear in the overall reaction. Part C. From the mechanism represented above, a student correctly deduces that the rate law for the reaction is rate equals K times concentration of NO squared times concentration of H2. The student then concludes that 1, the reaction is third order, and 2, the mechanism involves the simultaneous collision of 2 NO molecules and 1 H2 molecule. Are conclusions 1 and 2 correct? Explain. So conclusion 1, that the reaction is third order. We get our overall reaction order by adding the exponents, right? So we have a 2 here and a 1 here, And so overall, the reaction order is 3. So this first conclusion is correct, as the total rate order equals the sum of the exponents in the rate law. So of course it would be 2 plus 1, which is 3. So you have a third order reaction. Okay, but the second conclusion, that the mechanism involves the simultaneous collision of two NO molecules and an H2 molecule. That would be the simultaneous collision of 3 molecules, which we discussed was very rare and one of the reasons why these mechanisms exist in multiple steps. And we don't have any step here where an H2 is reacting or colliding directly with an NO molecule. Okay, so the conclusion is incorrect because all 3 elementary steps in the mechanism involve a series of collisions between only 2 molecules, and none of them involve a collision between NO and H2. Part D. Explain why an increase in temperature increases the rate constant K given the rate law in Part C. So the rate law in Part C was K times concentration of NO squared times concentration of H2. Okay, and we had talked about the only thing that we can alter to impact the value of K, the rate constant, was the temperature. So if you remember, there's that Arrhenius equation, K, where K equals, I'll simplify, constant A times e to the minus EA over RT, right? So if we increase the temperature, how can we demonstrate that this K also increases? Since an increase in temperature will increase the number of collisions that have enough energy to overcome the activation energy, the reaction rate will increase. Based on so the rate, we know the rate will increase. And the only way that rate can increase here, we're not making any changes to concentration, right? The only way that rate can increase then is if K increases. So how does that happen? Based on the Arrhenius equation, an increase of temperature would make the exponent less negative, resulting in an increase in the values of the rate constant.